Okay, that works. Now let's do the charger. Okay, our green one. And our black one. Okay, this one's a spare for now. Alright, that's it, we're all connected. Now let's see if it works. I guess I need power and not ground. I got neutral of that. Got neutral. So actually needs to go to line. That'll work. Alright. Camera time. Bah. Got chips in my teeth. Alright. So here's what I did. I went ahead and hooked up the new circuit, timer circuit, and controls. Works really well. I only currently have the high voltage and the charging circuit connected. So I'm going to show you kind of how this works. Alright, for now, I'm going to go ahead and use these switches. I do have it doubled up to these switches, but this is all like manual, override. This is all automatic. So that's how I'm doing this. Override, automatic. So here I can control charge and fire. Okay? And this also kills the charge circuit. I still need to add my safety resistor. I need to do that. Okay, so that's how that works. This portion of it is the auto fire. Okay? So it's automatically firing. Alright, now if I flip this switch, this is the stop. This is the repeat, or auto. So now it will just continue to run. Okay, now if we wanted to watch it, monitor it, and see what's happening, I can do that. Okay. Just want to see the rest of it here. Oh, that's the wrong mouse. There's the rung program. Inside this rung program, here, let's stop it. It'll automatically stop if you turn off auto after the last cycle. Let's look at the rung program real quick. Basically, it's just a first scan to initialize every time. Then you got a start and a stop rung, just like a normal rung. Internal relay, an internal relay, and a clock. Every 0.01 second. So every 1 millisecond, it repeats the cycle, and it checks for timing. That's how we're actually timing. Works really well that way. So we have millisecond timing increments. If I open this, this is my control. So I've got voltage, and don't worry about the labeling yet. I need to relabel some stuff more accurate. But let's go ahead and change the timing. The high volt's on. Let's only do 20, so that's 0.2 of a second. Let's go ahead. Oh, that's high volts. Hold on. Charging. Charging, it was at 50 milliseconds. Let's do 20 milliseconds. And then high voltage is on at 25. That gives me 0.05 milliseconds to turn off the contactor. And then let's turn on the high voltage for just a very short duration. Change our total time. And now, when we fire this, it will happen very rapidly. So I can do this manually. I can also control it from here. Okay. I believe that changed that. It may not have downloaded. Should have. Yeah, should have saved it. Let's go. So again, I can do auto. May need to download it. Anyway, see if we can get it going faster. Okay. I think I had to download it. I don't know how to do it automatically yet. We will have that option, but right now it didn't work for me. So here's one cycle. So let's do it fast. Oh, too fast, huh? Reset. I need to slow it down a little bit. Alright, we'll slow it down a little bit. A little bit too fast for me. Still pulling too much. But it's working. I need to control my incoming amperage a little bit. Alrighty, enough playing around for now. about a half a second cycles. Oh, finally killed it. What is it? I don't have but just 2 capacitors on here, so we'll turn down the amperage a little bit. Anyway, just thought I'd show you that it works. Now we can hook up the coils as well and play with the timing. I'm going to have to add external stuff for that. I don't have that yet. I'll be able to switch polarity with 2 different outputs. That way we can control the polarity of the coils. So there you go. Really quickly, I wanted to explain something with you on these coils. A couple of thoughts. Really enjoyed Bob's videos and his demonstrations on Smart Scarecrow Show. Some little hints here and there. I was thinking about these coils, and the collapsing magnetic field is maybe the most important part. Not the fact that there is a magnetic field, but the collapsing magnetic field. When you get that high voltage spike out of that coil, when you take power off this coil, it's going to throw you a high voltage spike in the opposite polarity. And I wonder if that high voltage spike, if timed exactly at the right time, will actually help the process. So that collapsing magnetic field might be a boost, and the high voltage spike output either gets fed to the other cylinder or can be actually used to fire this system. Okay, just some thoughts, some stuff I've been thinking about, but kind of interesting. I guess that's about it. Oh, I did want to show you one more thing. I forgot to show you this. Check this out. I told you my dad brings me stuff. I got a new shield. Ready? I'm gonna get it. It's a little heavy. I have to build a frame for it. How's this? Alright. It's got a little bit of a tint to it. Okay. Show you how this thing is. Alright. That might be my new blast shield. It came out of a bank. Yeah, a bank. It's the inside door of the actual bank. Right behind the main locked door was this. Okay? This is a 1/2-inch piece of some sort of really hard plastic. I really have no idea if it's bulletproof or shatters. I don't know. But it should stop an object, at least slow it down, right? It had a door on it. You can see that it got bent while opening it. I've also got the hinges right here that actually go on it. It's actually a door. So there's 2 hinges, right, on the edge plate here. So I don't think I'm going to use it. Maybe somebody can find some information about it. Molesworth, Hamilton. Has a date code, 485.